Okay, let's discuss the nature of variables. So, first, a nice simple definition. A variable is an event or behavior that can assume at least two values. It needs to be able to vary. So, for example, sex is a variable because you can have at least two values on that. You can think of lots of different variables that psychology uses. Age. You can imagine with age that you could be any number. I'm trying to think of the bottom or the top numbers, right? 0 to 130. I don't know what the oldest person ever has been, something like 120. We could get into a whole theory of what the maximum possible lifespan is, but that's not relevant to this class. So, but you can imagine you could be any number between, the minimum and the maximum possible ages, right? Because you're not just whatever year old you are, you're the year plus months plus weeks plus days of age. So you can imagine that age is what we would call a continuous variable. It could be any number, even fractions or decimal points along the way. Whereas sex would be a good example of something that's categorical. You're in this category or you're that category. So we have at least two values, and they can take different forms, right? Ooh, now this should look familiar to you because we've talked about operationism before. An operational definition is when we define our variables as the operations that are needed to produce them. So instead of having a good essentialist definition where we say all of us know exactly what is meant by a term, we have operational definitions for our variables. So for example, if I wanted to study intelligence, I might use the score that a person earns on an IQ test as my operational definition of the concept of the variable of intelligence. So this is kind of a tricky concept, and I oftentimes have students asking me questions about what do you mean by this operational definition? I thought an IQ test was a measurement of intelligence. How is this an operational definition? Because we oftentimes think of some of these these abstract concepts as concrete things, but intelligence is really just a concept. It's something that we all kind of think we know what it is, but if we really got pinned down and had to define what it is, we all might have different definitions. And so that's why it's really important that we use operational definitions for our variables so that anybody else will know what we mean. Okay, so when you say intelligence, you mean a score on the Stanford Binet. Okay, great. When I say intelligence, I mean a score on the Wechsler test. Okay, two different IQ tests. Or, okay, well, that's good. You guys, that's how you guys are defining it, but I'm going to define intelligence as success on the job, right? You might say, well, wait. There's so many other stuff that goes into success on the job. How are you going to use that as your operational definition? Well, this is what I'm going to use. This is my justification for why I'm going to use it. I'm going to use success on the job because typically IQ tests should be tapping into characteristics that are valued by the society. And how do we know whether somebody has valuable characteristics? Well, they tend to do well at work. Okay, well, I don't like your logic. I'm going to stick with my Stanford Binet, but I can at least appreciate that that's your definition. And so at least I understand. I understand what you mean by when I say intelligence, I mean success on the job. Okay. I don't have to agree with it. I'm not an essentialist. I don't have to agree with it. I just have to know what you mean by it. To give you another example from psychology, depression. Again, another concept, right? You all know what it means to be depressed, but what does it mean to be depressed? What is it really, right? That would be the essentialist question. Well, we might say for the purposes of our study that we mean depression as a score in the, maybe we'd say 17 or above on the Beck depression inventory. We're going to call depression for the purposes of this study. Or we might say we're going to have in our subject sample people who were diagnosed by a clinician with major depression. And that's how we're going to define depression. diagnosed by a psychologist or psychiatrist. There are different ways you could define these concepts. The key thing is we operationally define them for the purposes of research. All right, independent variables. I love this picture. I found it on the internet and it's just so, antiquated. And actually their list of sample independent variables is kind of antiquated also. You'll notice it's got reward and punishment, rest periods. I mean, these are very classic sort of 1950s and 60s topics that psychology really pursued. What I really want you to notice on this slide is, for one thing, we shorten independent variables to IVs. And it takes a little bit of practice of seeing that for you to lose your Roman numeral awareness and think, for what? Fours. This is IVs. So independent variables. These are the variables that the experimenter is going to purposely manipulate. So on this list from our old-timey picture here, you can see that the experimenter could be in charge of whether the participant receives a reward or a punishment or gets a rest period or has some kind of drug administered to them during the study. Is given this set of instructions or that set of instructions, or if they were assigned to do this task with the materials or to do that task with the materials. You can see on that list, those are all really good examples of variables that the experimenter can manipulate. The whole purpose for doing the research is to discover the effect of the independent variables. That's the whole reason for doing the research. So what we want to do is define our independent variables really clearly, control our independent variables very well so that we can determine whether the independent variable is really the reason, is really the effect that we expect. The independent variable is really having the effect that we're predicting that it will. Now, I thought I'd share with you some other types of independent variables. This probably isn't a completely comprehensive list. There are physiological independent variables where we're going to manipulate the physiological state of the participant. So that would be things like the drugs example from the last slide, right? Maybe we're going to administer caffeine pills so that the participant, their body is experiencing physiological signs of stress. And we want to see what impact that has. Something like that. So physiological, we're actually going to make them, experience cold or heat, or so that, their body temperatures being affected, or maybe we make them go some amount of time after eating before they participate in the study so we can see what effect hunger has. Or maybe we deprive them of sleep, or we wake them up whenever they're in REM stage or something like that. So they're deprived of certain, physiological states, things like that. Anything that you're doing that has to do with how their body or brain, their actual physical brain is functioning, would fall under that category of physiological. Experience independent variables would be where we're going to manipulate the experience that they're having, like the amount of training that they received, or what kind of learning they're going to be experiencing. Is it classical conditioning or operant conditioning or something like that? What is going on in the study that's being manipulated. So the experience that they're having. So for example, maybe it could be instructions. So for some of the participants, they are instructed to perform a task where they rate words for pleasantness, while other participants are given the task of checking to see whether the word contains an E. Those would be, instructions would fall under that experience category. So anything that we're in control of where we're making them experience one thing versus another would fall under that experience category. And then the final one is situational, which is where we're going to manipulate the environment. So instead of, something internal to the participant like physiological, or the situation is going to be manipulated in this kind of category. In the experience category, it would be instructions or tasks or what they're actually doing. In situational, it's like, is this room hot? Is this room noisy? Are you being tested alone or with another person there? Now you can see whether you could make an argument for some of these overlapping, right? Because if the room is hot, that might affect your physiology, right? If there's another person present, that might affect your experience. The situation might affect your experience. So you can kind of see how these overlap with each other. I gave the example on situational of the Hawthorne study that we talked about earlier in class, right? We've got low levels of lighting on the assembly line versus high levels of lighting on the assembly line. And what effect would that situational change have on productivity? So anything that has to do with the environment would be that situational component. Okay, so now that we know what variables are, let's talk about how we can use them to create two groups that would allow us to test that one independent variable with two groups effect on some dependent variable. So two-group design, this is the simplest controlled experiment that we can do, having just two groups to see if they score differently from each other. Now, in a two-group design, there's one independent variable, but there are two levels to that independent variable. Levels are oftentimes referred to as conditions. They're referred to as groups. That's why it's called a two-group design. So we have one independent variable that has two levels, right? Because remember, to be a variable, you have to have at least two versions or scores or experiences or whatever, right? So to be an independent variable, that means that there has to be at least two ways that independent variable can manifest itself. So that's why this is the simplest controlled experiment, because we're going to just have that one independent variable and it's going to have its minimum number of variations in the form of two levels. So typically, and you guys have probably been trained with this either in other psychology classes or maybe biology classes or other situations, other science classes, that you've learned about, an experimental group that receives the independent variable and a control group that does not receive the independent variable. But let's think back to the examples that I gave earlier. Let's think about the experience example I gave. You've got one group of participants who's rating the words for pleasantness, and the other group of participants who are looking to see whether the words contain ease. Okay. Sounds like they're both doing something, doesn't it? Like, what do you mean? And I just told you have one independent variable with two levels. So if we think in this kind of design, if we think about the pleasantness versus e-checker, really the independent variable is task. And one group or condition is the pleasantness group, and the other one is the e-checker group. So which one's experimental and which one's control? It's tricky in psychology, and I think I've already talked about this in previous lectures. It's tricky in psychology. Experimental and control group implies that one group is getting a treatment and the other group is not. The other group might be receiving a placebo. That's kind of what's implied in these terms, but in psychology, in practice, a lot of times we have, the two levels, and one is getting one version of the experience or the situation or the physiological change, and the other group is getting a different version of that, right? So it's a little bit tricky in psychology. Now in class, if we were together, I would administer the jelly bean experiment with you. So unfortunately, I'm just going to have to tell you what the jelly bean experiment is. So what I do is I have ordered from the internet very cherry Jelly Bellies and then Jelly Belly Tabasco flavored. And in real life, they do not look substantially different from each other. It's really hard to tell them apart. And you know how Jelly Bellies are. They're really vividly flavored, but the problem is they give you little subtle cues on the outside of what they might be. So for example, I was wanting to do buttered popcorn versus lemon, but buttered popcorn has those little white spots on it that really distinguishes it from lemon. So I went through all the different Jelly Bellies and I thought, well, these look really similar. So there wouldn't really be anything to cue you if in complete isolation, you happen to be the unlucky person who got the Tabasco. They sound like they're going to taste worse than they really do. They're not very hot. And they a lot of times, the people who eat them think they might've gotten cinnamon. So it's not that aversive, as bad as it might sound. So everybody is given a Jelly Belly in a little teeny tiny Ziploc baggie that I got off of the internet. And I swear, I think it's for packaging drugs. But one of my students pointed out you could also put earrings in it, like if you were a jewelry salesperson. So that makes me feel better. I was waiting for DEA to come check on why I ordered those baggies. Anyway, so I put because it's really, those baggies are barely bigger than the Jelly Bellies. So I put the Jelly Bellies into a little baggie, and then I attached to the little baggie response sheet like you're seeing here on the picture. And so I have age, just why not? I have their sex, why not? And then I asked them to rate the degree to which the flavor of the jelly bean met their expectation. I forgot one little step that I have them do before they fill out that piece of paper. And that is, they're supposed to take their Jelly Belly and look at it, think about what flavor they think it's going to be, really try and guess what flavor it's going to be. And then they get to eat the Jelly Belly. And then they complete that rating scale. So since we can't do it in class, I went ahead and pulled the data from the last time I ran the class face-to-face, and here's what I found. First off, you'll notice that I named the experimental group, I just called it the Tabasco group, the atypical flavor, because I thought that was sort of the more experimental thing to be doing, giving people Tabasco flavored jelly beans. And that left the cherry flavor to be the control group, the typical flavor. And what you can see is that every single person who received the Tabasco flavor gave it a rating of 1. So you see it at the very, very bottom there. Whereas the people who received the cherry flavored jelly bean gave more variety of ratings. The most common rating was 5, but you can see that the average score is something less than 4. So, but what you're seeing very clearly is that the flavor of the jelly bean, the typicality of the jelly bean, does dramatically affect the ratings that people gave for how well the jelly bean met their expectation for flavor. So this is a really simple 2-group design. This is the kind of results that you could derive from a 2-group design. Obviously, my research question is, kind of lame, but it's a good example of how you can have just 2 groups. You can get a very interesting effect. And if you ask maybe a more interesting question, you get an even more interesting effect. All right, so that's a nice simple 2-group design. We'll come back to that a little bit more and talk about it more later, but let's move on to participant characteristics. So this is oftentimes in the old literature referred to as internal variables, and that's what you're seeing on this old picture's chest. So we've got age, sex, experience, motivation, intelligence, personality, and health. And you might be noticing, well, wait a minute, didn't you say experience was one of the independent variables in the past? And really good catch if you notice that. What we're talking about with participant characteristics would be aspects of the participant, something that they bring with them. So clearly we can't manipulate these, right? I can't assign people to be a different age than they really are. I can't assign someone for the purposes of this study to be a different sex than they are. Things like that. I can't manipulate their level of motivation or other kinds of things. So these are aspects of the participant that we are going to use as independent variables. We're going to use these as if they were assigned and manipulated. The participants came to us already in their groups, but we're going to act as if they were independent variables. They're not real independent variables in the way that the independent variables that I was talking about previously are, because we cannot manipulate these independent variables. That lack of control makes it so that we can never be completely confident that the independent variable is the real important factor. So for example, if I find that people who are over 50 score differently on my dependent variable than people who are less than 25, it could be that age matters. It could be that really the variable that I'm focusing on, the age of the participants, is really what matters. But it could be that other incidental factors that go along with being different ages are what really matters. Things that I didn't take into consideration, but that go along with being different ages. So we always have to be a little bit more careful when we're using participant characteristics as independent variables, because we don't have control over those variables. So just always keep that in mind. We don't have control, and so we can't be as confident about our conclusions. So what am I talking about with regard to confidence? Now, if we do a typical two-group design using a manipulated variable, not one of those subject variables or internal variables that we were talking about on the last slide, but let's say you're being assigned to eat either a Tabasco flavored or a cherry flavored Jelly Belly. One of the key components to a controlled study is that I'm going to randomly assign participants to groups. So actually in class, it's almost exactly like what you're seeing here on the slide, because what I do is I take those, little Jelly Bellies that are attached to the little slips of paper, and I fold the piece of paper so it's a little easier to grab and put them all into a little bag, and I walk around class and people just draw one out, and that's how they get placed into their group. It's random assignment. So what random assignment refers to is every participant having an equal chance of being in either group. Now, if you take more advanced statistics as you go through your training, you're going to realize that it's not an equal chance per se of being in either group when you use drawing names out of a hat or a bag or something like that, because technically once one has been drawn out of the bag, then the next participant doesn't have exactly the same chances as the one before them did. Like, I will just say, for the purposes of this class, equal enough. Right? If you're really familiar with your statistics, you might be thinking to yourself, well, I mean, it's not exactly equal enough, right? So there are a limited number of slips of paper in there. Everybody draws one out and finds out what condition they're in. You can also do it using a table of random numbers. So if you have all of your participants pre-registered for your study, you can use a computer algorithm to tell you which of those participants should go into the experimental condition and which one should go into the control condition. I mean, there are a lot of different ways that we could do random assignment. The idea is you don't want to use any kind of bias in placing your participants into conditions. We don't want to have all the people who get there first. Let's say everybody's been assigned to appear at the lab at 10 a.m. and you need 10 people to be in the experimental condition and you need 10 people to be in the control condition. The first 10 people who arrive, you say, okay, that's random enough. I'll put them in the experimental condition, and then the next 10 I'll put into the control condition. You don't want to do that because that can introduce bias. There may be a systematic reason why some people arrived at the lab earlier than others, right? It might be a personality variable or other factors, and you might accidentally be causing those factors to have an impact on performance on your dependent variable. You want to wait till all 20 have arrived and then go through the big random procedure. Either draw their names out of a hat. You already previously had set up the table of random numbers and you're ready to go, or whatever. But you want to make sure that there is no system to help individual participants get placed into the groups. Now, it's really important to keep in your mind the separateness of random assignment versus random selection. Random assignment is referring to how participants get placed into groups. Random selection is how participants get selected, how a sample gets selected from a population. Completely different, and generally random selection is not relevant in a psychology controlled study. Sometimes in medical studies it is. Like, people will volunteer to participate in a controlled study and then they are randomly selected. Some subset of those volunteers get randomly selected to actually participate. But in psychology studies, we rarely do that. Generally, our participants sign up and we run them. So we rarely use random selection, but we, in any controlled study, need to use random assignment. Now, we need to have at least 20 participants for randomness to really sort of pan out in the long run. Here's an example of a study of carvedilol as a treatment for cholesterol. And so, or is it for blood clotting? I can't remember. Not that kind of doctor. So they start off, they've got 53 eligible patients and they have 23 who end up non-randomized. You see that there's 13 who refused. Remember, I showed you in participant selection, you can have the opt-in or the opt-out. So it sounds like this study was originally an opt-out, and 13 of the 53 patients opted out. And then we have others who had health-related reasons why they weren't included in this study. So that left them with 30 randomized patients. Now you'll notice they did not do an even randomization. They ended up with 20 participants in the carvedilol category and 10 who received a placebo. And you might be curious why they would do that. Generally, when you're onto the stage of testing a new drug, that you have seen from earlier testing is seeming to have a good effect. You want to have more patients taking the drug than not taking the drug, because we have pretty good indicators that it's actually working, but B, we really want to start understanding side effects. And so you need more people taking it so you can get a better picture of the side effect. You still need some people taking control placebo, because you want to be able to eliminate the interpretation that just the act of taking something was causing these side effects, or just the act of being in a study caused these side effects. So you want to make sure you still have those control people, but the 20 taking the carvedilol will give us more information about side effects. But you'll notice they have 30 randomized patients. 30 is a really good cutoff for the two-group design. I always start with 20, depending on what I'm studying, frankly. If it's something that I know that people will be very similar on, like memory capacity or something like that, you can start with 20 and you probably will have enough power to actually run your statistics and be confident. But if you are studying something that people vary on more, they are, maybe it's an attitude issue is the dependent variable, or, something that people might show a lot of diversity on their responses, you want to have a larger sample, because you want to make sure that you don't have outliers really affecting your mean score. You want to make sure that you're getting a really good picture of what people tend to do. Your sample should really be representing your population. So we use random assignment so that in the end, we'll end up with independent groups. We don't want the two groups to somehow be actually dependent on each other, like the early arrivers versus the late arrivers in my example I gave before. That would be, they're sort of interdependent in the sense of you got placed in your group relevant to the other participants, right? It should be purely random. You want independent groups so that this group of people is separate from that group of people. You want them to be independent. This will allow us to make what are called between subjects comparisons. So in this picture that we're looking at with the carvedilol, we're going to make comparisons between those 20 participants who took the drug and those 10 who took the placebo. Those are two groups of people that are independent of each other and allow us to make comparisons between the groups. Because we want to make comparisons between the groups, we want to use this randomization process to help ensure that those two groups start off fundamentally the same. What that means is we want to make sure that any individual differences between the participants or patients in the carvedilol example, any individual differences need to be spread out across both groups. You don't want to inadvertently end up with, let's say, all the people who would have scored high on your dependent variable being in one group and all the people who would have scored low on it being in the other group. We want people who are naturally good at this task or naturally are going to respond well to be in both groups, and people who are naturally not going to do as well to be in both groups, so that we can really test the power of that independent variable. We don't want to accidentally have our assignment strategy determining performance on the dependent variable. So random assignment really helps us to get around those problems. And you're going to be the most confident with your random assignment if you have at least 20 participants that you're going to be randomly assigning. I think our book advocates for 30. So somewhere between 20 or 30, I was trained 20 is adequate, but these days they've really started boosting up sample sizes. So it may say 30. 20 to 30 is a really good round number. All right. I think I've been talking for a while, so I'm going to go ahead and take a break here and we will reconvene to talk about the two-group design.